Here's your lesson on simple interest. Now, when we're talking about simple interest, we're pretty much talking about two different kinds of situations. Either money invested, so we're talking about money invested into pretty much something like a savings account, or money borrowed. And this would be something like borrowing money to buy a house, or borrowing money to buy a car, or just borrowing money using a simple interest rate. Now, interest is an amount of money that is added to the amount borrowed or invested. This is something you're probably used to hearing, maybe just in casual conversation. But what happens is, when you invest money into a savings account, that money doesn't just sit in there as an amount of money. If you put $100 into a savings account, even if you never touch it again, the amount of money is going to increase because a simple interest rate is attached to that, and a percentage of that $100 that you put in is being added over time. So you're actually earning money. The bank is actually paying you for using that money. They're paying you for you putting that money into a savings account and not touching it. And the same is true for money borrowed, except for when you purchase a car, for example. When I bought my car, it was about $16,000, but I'm not going to just pay $16,000 because I was loaned money by a bank to purchase the car. And so because I'm making payments over time, I have to pay the bank for letting me borrow that money. So I'm paying them a percentage of the money I borrowed, and that's called interest as well. So I'm actually going to end up paying more than $16,000 over the time that I have to pay for my car. Interest is added at a certain rate over time in order to benefit the person for investing or to pay the person being borrowed from. So as I just said, if I'm borrowing money from the bank to pay for my car, then the interest is going to be a percentage of the total that I pay to the bank. And then same way, if you put money into the bank, if you invest money, the bank is going to pay you a percent for having your money in the bank. Okay? We use the following formula when working with simple interest in a simple interest scenario. And it's going to be I equals P RT. Okay, and each of these variables stand for a very particular part of the scenario. It's always going to be interest equals these three items times each other. The formula doesn't work if you put principal equals I times R times T, or if you want to switch R and I, it doesn't work. The only thing that can be moved around or switched are the order of these three because of the commutative property of multiplication. Okay? The equation here is a formula that is fixed that works for simple interest. So it's always going to be the amount of interest equals these three, not T equals the other three or something else. So you are allowed to change the order of these three because of the commutative property, but that's the only order that's allowed to be changed here. So it's very important to maintain that order, okay? Excuse me. What each of these items means is I stands for interest, and interest is an amount of money, okay? P stands for principal, and principal is an amount of money, but the principal is the initial amount of money. So if I put $100 into the bank, that's the initial amount, the $100. If I borrowed $16,000 from the bank to pay for my car, that initial amount, the very first amount that I borrowed, that's the principal. Okay? R stands for interest rate. Now, I make sure to tell you that it's interest rate so that you don't get interest rate and interest mixed up. The interest rate is a percentage, but the interest is the amount of money. But the interest rate is a percent. And when we're calculating with a percent in an equation, we must use the decimal equivalent. You could use the fraction equivalent as well, but what we know is that it's easier to move from a percentage to its decimal equivalent than to its fraction equivalent. And then T stands for time in years. It's important that you understand that it is in fact years. So if it was 5 years, you would use the number 5 in this place. But if they were to tell you in a scenario that it was paid over 6 months, you would not put 6 in that place. You would put 1/2 because 6 months is 1/2 of a year. So be very sure that when you are talking about time, that it's years. Okay? Because we're now familiar with solving equations, I can say that as long as you know 3 of the values, you can always find a 4th that may be unknown. However, it is crucial that you understand the meaning of each variable in the simple interest equation. This is because some of these story problems are going to be written in order to mislead you. They will give you 3 values, but those 3 values might not be exactly what you think they are. So if you understand the meaning of what it is you're looking for, the meaning of what it is you're solving, then it's really going to help you, it's really going to benefit you. If you just are looking for 3 numbers to plug into 3 places, it's absolutely meaningless. So I'm going to reiterate here what these things mean. So interest, again, I stands for interest, and it's the amount of money that is earned or owed in addition to the principal. Okay? P is for principal, again, which is the initial amount either borrowed or invested. Remember, simple interest works in 2 situations. If you put money into the bank in order to earn interest, or if you borrow money, then you're going to have to pay additional interest when you pay that money back. Okay? R stands for interest rate. That R is the rate, okay? It's the percent of the principal that is added to the total amount each year. So the interest rate determines the interest because it's a percentage of the principal. And then T, again, is time measured in years. So the amount of time that you take to pay back something is going to influence how much money is paid in interest because the rate is a percentage on the principal each year. Okay? So we're going to try some examples using the equation. And we actually start more challenging and then end up a little bit easier. I thought that this way I would have your focus the most. So, our first example is, Tessa deposits $4,000 in an account that earns 7% simple interest. How long will it be before the total amount is $6,500? When you're doing a simple interest problem, you need to ask yourself a couple of questions. What do I know? And what do I need? All right? And then also, what is the question that I'm answering? So what do I need is kind of the same thing. So I know that I need to find out what the interest is, what the principal is, what the interest rate is, and what the time is. Now, the question asks, how long will it be? So I'm guessing I'm going to be solving for time, but I'm not sure. So I should be able to find the amount in interest that was earned, the amount of principal, which is the initial amount, and what the interest rate is by reading this scenario. So as I read and I go back, Tessa deposits $4,000. Deposits $4,000. Well, that's the initial amount. So that's the principal. Okay? So we can say that that's $4,000. Now, it earns 7% simple interest. So that is going to be the interest rate. 7%. But I don't calculate with percentages as the whole number percent. I need to change them to their decimal equivalent. And in this case, a percent being a comparison of a number to 100, 7% is 7/100ths. So as a decimal value, we can say that's 0.07. And that's what we're going to use in our formula up here, okay, in order to get an accurate amount. And then interest. It is going to be so tempting for you to grab this number just because it's the third one and plug it in for I. However, it asks you how long will it be before the total amount is $6,500, the total amount. Remember that Tessa deposited $4,000 to start with. So that $4,000 is included in that total, but money was added to it. How much was added to it is going to be the interest, the amount of money. So if I had $6,500 and I had initially deposited $4,000, the amount that was added to it, well, I would have to subtract $6,500 minus $4,000, and that's $2,500. So that amount is the interest. Okay? So I have 3 of the items. I know 3, so therefore I can solve for the 4th, and t we're just going to keep as t. So now that I know what I'm working with, and this is such a good way to organize your thoughts to be sure you're ready to use the formula, now I go ahead and plug them in. So I is 2,500 equals P, which is 4,000, times R, which is 0.07 times T. Now, I multiply these two first, and I'm going to come down here and do that quickly. It's 28. That's going to be all zeros, so I give it 2 decimal places, making sure I'm good. So now I have 2,500 equals 28t. Now, in order to solve for the amount of time, I need to undo multiplication, okay? And I do that by dividing. So the amount of time it's going to take is 2,500 divided by 28. So I, again, need to come over here and do that math. I'm guessing it's going to be 9 times 400 times 0.07. It's 28 times t. It's going to be a long time, isn't it? Let's see. 28 times 9, that's 72, 18, 252. So it's going to be 8. So 28 times 8, that's 64, 16, 22, 224. That's 6 to 60, and I know that's going to be 9, so that's 252. Let's just say, how long is it going to be, approximately, before the total amount is $6,500? 89, what does T represent? Years. Holy cow. 89 years? That's pretty intense. 7%. To earn $2,500 in interest. 89 years. That's really, really intense. I meant to say YRS. But that would be the solution to this problem. So if you really wanted to earn $6,500, would it be worth waiting 89 years? Maybe. Maybe if you were leaving it to somebody. It's worth a shot. Yeah. Okay. Here's another simple interest example. Matt borrows $5,000 to buy kitchen appliances. How much interest will he have to pay? If he borrows the money for 3 years at a 4% simple interest rate. So he borrows $5,000, that's the initial amount. So that's my principal. How much interest will he have to pay? So I don't know. But for 3 years at a 4% simple interest rate, and we know that's going to be 0.04. So I don't know I, it's going to stay I. So I'll say I equals 5,000 times 0.04 times 3. I love this because I don't have to solve for, I'm solving for I, but I can just multiply the 3 together, right? 3 times 0.04 is going to be 0.12, and that's going to be 5,000. So 5,000 times 12 hundredths is, and again, let's hope I do this right, because I'm still unsure about the last one, but I'm hoping that it's good. That's 10, 1, 2, 3, and 5. First of all, that looks like a lot, but then we place the decimal, $600. So I equals 600, and again, we know that's an amount of money. How much interest will he have to pay? If he borrows the money for 3 years, I equals 600. So he's going to pay $600. How much total would he have to pay? If he paid $5,000 and then $600 in interest, the total he would pay would be $5,600. This is why you have to be careful when borrowing money, because if you borrow it, you have to pay to borrow it. So you're not just paying for $5,000 kitchen appliances, you're also paying $600 to borrow the money. So the total you're going to end up paying is $5,600. This is often why people like to pay things off faster. And then this is our final example. Sam earned $364 in interest on a $1,300 investment that she had in savings for 7 years. What was Sam's simple interest rate? So she earned $364 in interest. That's going to be my I. On a $1,300 investment, so that must be how much she put in the first place. So that's your principal. For 7 years, so that's going to be my time. So my R is what I'm solving for this time. So I know I equals 364 equals 1,300 times R times 7. This is where I really emphasize using the commutative property of multiplication. You're allowed to move these around. So you can say 364 equals 1,300 times 7 times R, so you can get those together first. Now 1,300 times 7, I don't know why I'm doing it like that, that's going to be 9,100 R. Now when you divide here, you realize that you're going to get a number much smaller than 1, because 364 91/100ths is certainly less than 1. Well, you're going to get a decimal value, and that decimal value is going to translate to a percent, because remember, when we calculate it with a percent, we use the decimal equivalent. So let's see if I can do this really quick. This might be kind of fun. 9100 into 364. Remember to put your decimal place and a few zeros here. 9100 doesn't even go into 3,640, but it will go into 36,400. I'm going to guess, let's try 4 times. I'm thinking it's probably 3, but we'll do this anyway. And then that's going to be 36. Woo! There we go. 36,400. How nice is that? I'm done. Subtract, I have 0. So I had 0.04 as my R, but remember that this is not 0.04%, it's 0.04, 400ths. Think about it that way. 400ths comparison to 100, our percent is therefore 4% to answer the question. Always be sure you answer the question appropriately. There you have it.